Alright, so today's notes are going to be on your note sheet that I gave you today in class. And we're going to go ahead and get into some applications with trig. So we're going to head back into the word problems. First thing I need you to do is grab your calculator, click mode, and set it back to degrees. Okay, so get out of your radians that you were in yesterday. What you're going to do for each of these is you're going to draw yourself a picture. Okay? So the first one, from a point on level ground, 80 feet from the base of the Eiffel Tower, the angle of elevation is 85.4 degrees. Approximate the height of the Eiffel Tower to the nearest foot. So always make sure you understand what you're rounding to. And we're going to go ahead and draw ourselves a little picture. So there's theta. So you're standing on level ground, 80 feet from the base. So when you see base, we know that that goes on the bottom. So put your 80 here on the bottom. The angle of elevation. Angles of elevation are always here in the corner. So in where our theta is, we're going to change it to be 85.4. It wants to know the height of the Eiffel Tower. So which of these pieces would measure height? This vertical piece is how we measure height. So we're going to put an X there. Now we're going to go ahead and label the O, the A, the H. So from my angle of elevation, I have that this is my opposite, my hypotenuse, and my adjacent. So SOHCAHTOA. Almost said it again. Alright, I have O and A. So O and A, I need the tangent function. So the tangent of 85.4 is equal to x over 80. What do? We're going to go ahead and put a little 1 underneath there, and we're just going to solve the proportion. So I get x is equal to 80 times the tangent of 85.4. Alright, so grab your calculators and type it in. I got the old calculator because it doesn't have anywhere near the glare of the new. So 80 times tangent 85.4, and I get 994.36, but it says to round to the nearest foot, so I'm going to say 994 feet. Alright, so far so good. Let's try number 2. A guy wire is 13.8 yards long and is attached from the ground to a pole 6.7 yards above the ground. Find the angle to the nearest tenth of degree the wire makes with the ground. Right? So again, let's draw ourselves a triangle. So the wire is attached from the ground to a pole above the ground. So this would be my pole. Do you agree that's the wire? And this is where it's like the peg where it's being attached. So I have the wire going from the top of the pole down to the ground. It says the wire is 13.8. And it tells me the pole is 6.7. This time it wants me to find the angle the wire makes with the ground. So here's the wire, here's the ground. I'm looking for this angle, theta. Alright, label your O, your A, your H. So opposite is the pole, the wire is my hypotenuse, and that must be my adjacent. So again, if you need it, here's SOHCAHTOA. I have O and H. So O and H is sine. Now this one's going to look a little bit weird to you. So it's going to be the sine of theta is equal to, sine wants O over H, 6.7 over 13.8. Now what you need to do is you need to work backwards, right? To find this, to find theta, you divide by sine. So now what I want you to do is do that. Take the inverse sine, so hit the second button, sine. If you have an 83 or above, it puts in the parentheses. If you're using the old 82 like me, you're going to need to input your parentheses. So 6.7 divided by 13.8. And I get, and I'm going to the nearest tenth, so I'm going to call it 29 degrees. Alright, So far, so good. Moving on to number 3. Alright. You are standing at ground level, 800 feet from Mount Rushmore, looking at a sculpture of Abraham Lincoln's face. The angle of elevation to the bottom of the sculpture is 32 degrees. The angle to the top is 35. Find the height of Lincoln's face to the nearest tenth of a foot. So this one's going to look a little bit weird. You did these when you were in geometry, but let me see if I can... And again, by no means am I an artist, but you're over here at the ground. So there you are. You're 800 feet from Mount Rushmore. So do you agree that you're 800 feet away? Here's Mount Rushmore over here. You're looking at Abraham Lincoln's face. The angle of elevation from the bottom of the sculpture is 32 degrees and to the top of the sculpture. So old Abe is up here somewhere. There's old Abe. So what you're going to do is find out that from the ground to the bottom of his chin, or face, is 32 degrees. And from the ground to the top of his face is 35 degrees. So this picture looks awfully complicated to me. So what I'm going to recommend we do is go ahead and separate it into 2 triangles. So do you agree that you've got this first little triangle, that this is 800, this is 32, and I'm going to look for that height. And that would give me the height from the ground to the bottom of his face. Do you agree that you also have this bigger triangle? And that angle of elevation is 35 degrees. I'm still 800 feet away. And I'm going to get this would be to the top of his face. Alright? So let's see what we can do. I want you to label the O, the A, and the H. So from your 32, directly opposite you is X. Your hypotenuse is here, and that means the 800 is adjacent. So you have an O and an A. So there's your SOHCAHTOA. O and A is tangent. So you have the tangent of 32 is equal to, tangent wants O on top of A, so X on top of 800. Slap a 1 underneath him and cross multiply. So X is equal to 800 times the tangent of 32. And it wants us to round to the nearest tenth. Okay, so grab your calculators, let's type that in. And did you get approximately 499.9? Alright, so we know that it's almost 500 feet from the base to the bottom of his face. Let's try this other triangle. Alright, and I'm going to go ahead and freeze my picture, and I'm going to let you label the O, the A, the H, and see if you can figure out how far it is from the bottom to his top of his head. So pick your trig function. I feel like I should have some music playing in the background, but I don't have any. I could sing to you, but then you would just mute me. So let's not go there. All right, you ready? Probably not. So let me give you a couple seconds longer. Okay, I got that was 560.2, so I did the tangent and then I multiplied. So, go back to your original picture. You know that it was 499.9 here, and we know that it was 560.2 from here to the top. So my question is, what is the height of the statue's face? So I'm going to take the maximum height from his head minus the base of his face, and that would be my answer. And I get 60.3 feet. Now, the next two are going to be a little bit trickier because now we're talking about harmonic motion. So what I want to do is have you go ahead and put this note sheet away for a minute, and let's take some notes on simple harmonic motion. All right, simple harmonic motion. Examples of simple harmonic motion are a vibrating guitar string, a swinging pendulum, an object attached to a spring. What happens is that, like, imagine you had an object attached to a spring, right? You pick it up, you pull it down, you let it go, and it boing, 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 and each time it gets a little bit less, right? So that's what we're going to be doing. Now, there are two equations for simple harmonic motion, and they will actually give you the equation, whether it follows the cosine curve or the sine curve. So it's either D is equal to A cosine, okay, and this W is like a little fancy W, but I'm just going to write them as regular W, okay, or displacement is a sine WT. Okay, so let's explain what each of those mean. D stands for the distance from the origin. In other words, it's how far did you pull the spring down before you let it go. A is the amplitude. And again, we're going to put the absolute value. It's the maximum displacement. And I apologize. This is the one that tells you how far you pulled the spring initially, not D. So amplitude tells us how far we pulled the string. Okay, two more. The period, remember, is the time it takes to go through one cycle. It's defined as 2 pi over W. And the last thing we need to talk about, T is just time. And then frequency is the number of complete cycles per unit of time. And it is defined as W over 2 pi. Okay? This is one that I'd like you to know. I like finding the frequency and knowing that the frequency and the period are reciprocals of each other. Alright, so we're going to do two that don't require the word problems, and then we'll pick the word problem page back up tomorrow. Alright, so example 1. Complete. So I'm going to give you a function, d equals -8 cosine pi over 2t. I want you to give me A, its maximum displacement. Then I would like to give me the frequency. And finally, I would like you to give me the time required. To complete a cycle. Okay? Alright, so I have my function. I'm going to go ahead and label this number 1. I think we're going to do a second one as well. Alright, the maximum displacement. Where would I find the maximum displacement? That's this lead coefficient. But it's going to be the absolute value of -8. So I'm actually going to pull this item 8 units down. In this case, it is down because it's negative. If that had been a positive 8, I would be pulling it up. Okay? The frequency, remember, is defined as W over 2 pi. So where is W located? W is located right here. So I'm going to do pi over 2 all over 2 pi. Now, complex fraction, can't leave it, so I'm going to go ahead and multiply by the reciprocal. So I'm going to multiply both top and bottom by 1 over 2 pi. So now this goes away, and in the numerator I get pi over 4 pi, and what happens? These pi's cancel. Now be careful, what is left in my numerator? 1/4. Okay, now, because it's going to be word problem, I want to go ahead and give it some units. It's 1/4 inches per second. Now, to get the time required, we can go through a whole gobbledygook, or I can know that the time is really the period, so I just need to flip this guy and tell you that the time required is 4 seconds. Okay, let's try one more. Let's say d is equal to 1/3 sine 2t. Again, I would like the same thing. I'd like the maximum displacement. I'd like the frequency. And then I'd like the time required. Alright, so let's try. First thing, get your maximum displacement. So where would that be? Write this number, the coefficient right in front. So it's the absolute value of 1/3, which is 1/3. To get the frequency, I know that it is W divided by 2 pi. So let's fill in. What is W? W is right there, 2 over 2 pi. Now what's weird is that your pi's aren't going to cancel this time, but that's okay. You've got a calculator. We're going to go ahead and use it. So I'm going to do 2 divided by 2 pi, and use your pi button. Okay, so 2 divided by 2 pi. I'm going to go ahead and put that in parentheses just to be safe. Ooh, great day in the morning. And you get 0.32 inches per second. Now, when I ask you for the time required, you go over here and you're like, oh, Ms. Hoffman, I can't give you the reciprocal of that. I mean, we could. It would require a little bit of work. But why can't I go back over to here and say, well, you know what? It's just the reciprocal of this original guy. So I'm going to write it as 2 pi over 2. Now here my 2's cancel, and pi is approximately 3.14 seconds. Okay? And I think we'll stop there, and tomorrow we'll head out and do the rest of those notes on your worksheet. You guys have a great evening, and I'll talk to you later.